In this video, I want to talk about calculating variance and covariance, standard deviation, and correlation from historical data. So I've made up some returns for Coke and UPS. The first step is to find the average returns for each stock. So the 5 years for Coke are right here. The average would then be 12%. Same thing for UPS. Here are the 5 years of returns. Get the average. That's 8%. So this 12% average return for Coke is my best guess, my best estimate of what the returns will be next year. So that's my expectation of the return next year. To find the risk, I'm defining risk as the difference between what I expect and what actually happens. So if I expected 12% every year, but here's what actually happened, what's that difference? That's the deviations. So I take the 14 minus 12, 10 minus 12, each one of the returns minus the expected return of 12, and here are the deviations that I get. Notice when I add these up, they add to 0. Notice when I add up the deviations for UPS, each return minus expected return of 8, it also adds to 0. So that tells me no information. Here's the intuition and a way to think about it. If the class average was an 85 and you made a 90, you made 5 above average, your deviations plus 5. Your friend made a 75, their deviations minus 10. If I take everyone in the class and add up the deviations, their score minus average, it always sums to 0. So it's no information, doesn't help me at all. So what we do is we square those returns. Square the deviation. So 2 squared is 0.04, minus 2 squared 0.04. Sum those up. You get the variance, and I'm going to represent variance with sigma squared. So sigma squared Coke is defined as the variance of Coke. It's going to be the sum of the squared deviations divided by, and you'll see it different ways here, n or n minus 1. Stats class may matter a little bit more than finance class. N minus 1 means it's a sample of all the population of all the returns. So I don't have every return for Coke right here. I just have a sample of those returns. So divide by n minus 1 instead of n. If I had the entire population, I would divide by n. Now that doesn't really matter in finance as long as you're consistent. So sum those up, divide by n minus 1, and here's the variance, which is a really small number, right? Take the square root and have the standard deviation. And we tend to think in terms of square root because of the following. If I draw, and this is not going to be a good drawing, but you can deal with it, the normal distribution, and I have the average return here is 12%, so the average return is 12, plus 1 standard deviation. Let me round this off to 3%, just to make it easier to do. So between 9 and 15, I'm in this area about 68-ish% of the time. 6 to 18, that's 2 standard deviations. That's about 95% of the time. And 3 to 21, I'm in that area about 99% of the time. So again, that's not precise with the stats, but that's why we use standard deviation, because it maps back to this normal distribution. Alright, so let me pull this off the screen real quick. So now I have my standard deviations, and this is the risk of Coke, the risk of UPS. I want to find the covariance, and the covariance is how they move together. So rather than take the deviation squared, rather than this 2% and squaring it, I take the deviation of Coke and the deviation of UPS and say, do they move together? In other words, I'm looking for the covariance is the relationship. If one goes up, and by up I mean not up as in up 9% or up 14%, but above its expectations. Coke was above its expectations and UPS was below. That means they're moving in opposite directions. Here Coke was below expectations, UPS was above. So 4 out of the 5 times, no, the first 3 times they move in opposite directions, and the last 2 times they move in the same direction. So sometimes they both beat expectations, sometimes they're the opposite of each other. How can I measure this precisely? I multiply the deviations together, the 2 times minus 1, minus 2 times 1. I take those and I sum them up, and I call this the covariance of Coke and UPS. And all I'm doing here is I'm taking the sum of the deviations and dividing by n minus 1. So that's going to be my covariance. And that number is here, 0.004. I don't know what that means. I know it's positive, so I know they tend to both beat expectations or both be below expectations at the same time, but I can't really describe exactly what that is. But if I have correlation, you remember correlation from other classes is always between 1, and that's a lower Greek letter row, lowercase Greek letter row, between Coke and UPS, should be a comma, is always between -1 and +1. +1 means, hey, it's the same thing. They're doing exactly the same thing. They're tracking with each other. -1 means they're exact opposites. If one does something, the other does the opposite. 0 means that there's no information. You tell me what Coke did, I have no idea what UPS did. So the way I come up with that measure, I define the correlation of Coke and UPS, or any two assets, as the covariance of the two assets, Coke and UPS, divided by their two standard deviations. So this will be the 0.004 divided by 0.0292 times 0.0316. Again, there's rounding in that 4 probably. Not sure exactly how much rounding's in there, but anyway, that comes out to be 0.4339. This gives me my correlation, and this is really the number that I want to talk about the most. If I'm going to do a presentation and tell people the risk, I quote the standard deviation and the correlation. I rarely ever quote the variance and the covariance. It's important to realize I have to calculate the standard deviation and the covariance first before I can calculate the correlation. And just one last thing, notice what I'm doing. I'm getting the scaling effect here. I'm seeing, here's a covariance. Let me divide by the two standard deviations that force this to be between +1 and -1.